Alright, so now we're going to talk a little bit about special crosses. One of the things that we frequently have to deal with in genetics is unknown. So say for example, you have an individual with a dominant phenotype and you don't know if they're homozygous or heterozygous. There's a special way to solve that. You can do something called a test cross. A test cross is a mating between an individual of unknown genotype and someone who is homozygous recessive for that trait. I gave cats some special treatment earlier, so this time we're going to use dogs. So here are some Labradors. There's a black lab on the left and a brown lab on the right. Black is dominant to brown. Let's say you have an individual dog that is black, and you don't know if your dog is homozygous for the black gene or not. You can breed that dog to a brown dog, and that will tell you whether or not your black dog is homozygous or heterozygous. So how does that work? Well, if your dog is homozygous for the black gene, all of the puppies will be black. But if the dog is heterozygous for the black gene, half of the puppies will be brown. This is because the brown dog can only ever give the recessive trait. So if brown puppies show up, that means that a second recessive trait must have been in the unknown dog. Now let's talk about how we can think about these things for people. A lot of times when we think about genetics for people, we use something called a pedigree. A pedigree is really just a chart that shows how people are related to each other and what generation they're a part of. When we look at a pedigree, there are a few things that tell us information that we need. One is the generation that individuals are part of. So for example, we might consider generation 1 here to be your grandparents, generation 2 your parents, and generation 3 might be you and your cousins. Within each generation, we also number individuals so that it's easy to talk about them. So we might say, we want to talk about individual 3 in generation 3. That would be the filled in black box on the bottom row. In addition to this, circles are going to represent females and squares are going to represent males. And individuals that have the trait are going to be filled in, and individuals that don't will be white. Now we're going to look at a pedigree that's based off of 2 possible traits. One of them is a straight hairline, and the other one is a widow's peak, or the peak that appears above the forehead. The widow's peak is dominant to the straight hairline. So let's look at a pedigree for this family. You can see that the family consists of a lot of individuals that do and do not have the widow's peak. Now we want to answer a question. That question is, what are the possible genotypes for everyone in the family? The easiest way to start thinking about pedigrees is to look for individuals that have to be homozygous recessive, because you know automatically what their genotype has to be. So in this case, that's going to be everyone with straight hairline. All of the people who have straight hairline have to be homozygous recessive. Now we can think of what are the likely genotypes for all the other individuals. If a parent with widow's peak has a child with straight hairline, they must be a carrier for the straight hairline trait. That means that Al, Beth, and Debbie all have to be heterozygous because they all have children that have straight hairlines. That also means that Henry and Isabel in generation 2 must be heterozygous because Kristen, their daughter, has a straight hairline. There are 2 individuals that could possibly be homozygous dominant, but we don't know, and that's Evelyn and Libby. This is because we don't know if Evelyn or Libby are able to have children with straight hairlines, so we can only write their genotype as H-. Now let's try pedigrees from the other side. Let's try drawing one. In generation 1, Frank married to Judy. Both have normal wild-type phenotypes. Evelyn married to John, and both have wild-type phenotypes. This means that we have 2 married couples. We can draw them. Squares represent the boys, Frank and John, and circles represent the girls, Judy and Evelyn. Since none of them have any traits, they would be open or white. And this is generation 1. In generation 2, we're told that Frank and Judy have 3 children, Dottie, Francis, and Eve, and all of them are normal. Evelyn and John have 2 children, Robert and Carrie, and Robert has hemophilia A. So we need to add 3 children for the first couple and 2 children for the second. In this case, one of the children will be filled in. That's Robert. He has hemophilia A. In generation 3, we're told that Eve marries Robert, and they have 2 children, Payne and Kathy, who are normal. So we need to add generation 3, and we need to have them have 2 children who are not filled in, because they're normal. Okay, so drawing a pedigree is pretty straightforward. You're just going to draw all of the individuals that are mentioned.